Good day everyone, we are Group 8 Finite Element Method Section 2. Today we will explain to you guys about finite element analysis of a component that we found on a aircraft. For our analysis, we choose the main strut piston landing gear of the aircraft. The load cases that we applied to undergo the finite element analysis are the static force at the top part of the main landing piston and the distributed load on the forehole for the strut. For the strut, we can see at figure 2 here. Analysis of the force exerted on the main piston can be simulated using SolidWorks. From this analysis, the model of aircraft that was chosen to undergo analysis is Embraer FEM 100, where it is a light jet with 3 pairs of landing gear. The empty weight of this aircraft is 3,275 kg, and the maximum landing weight for this aircraft is 4,430 kg. The design finite element model for the main strut piston landing gear of Embraer FEM is shown in figure 2 here. For mesh conversion study, the table shown here indicate the maximum von Mises and maximum displacement that we get after running the simulation. As you can see here, we repeated 4 times the simulation 4 times using 4 different element size, which is 10 mm, 20 mm, 30 mm, and 40 mm. For convergence study, the element E needs to be inverted so that we can plot the graph, the maximum von Mises, and the displacement value. From the above two graphs, you can see that the maximum von Mises, stresses, and maximum displacement occurred when the 1 over E is at 0.1 mm, which is the element size of 10 mm. On the other hand, the minimum von Mises stress and the minimum displacement occurred when the 1 over E is at 0.025 mm, which is the element size is 40 mm. The trend line of both of the graph is logarithmically increasing. Also from the graph, we can see the graph begin to flatten at 0.1 mm, which is at the element size of 10 mm. This means the convergence point at this component is at the size of 10 mm. Hence, the 10 mm element size is selected from this point as the element size for all the simulation conducted.
Okay, hello, my name is Imanrullah from HAPIZAL, and I will explain the load test 1. So for the load test 1, we will study when the aircraft is in static position. As we know, the aircraft have 3 landing gear, as we can see here. So with the 3 landing gear, we will only calculated 1 of them. So in the report, I already calculate the force needed, which is 14.868 kilonewton acted on one of the main piston landing gear here. So that is the force acted on the top of the main piston, and then the boundary condition is here, which is the 4 bolted holes and the 2 mounting ports. So that is how my simulation is being conducted. After conducting the simulation, we can see the results in the left side. So here is the results. And so you can see the color of the simulation is different. So you can see the top part and the 2 parts here is blue, but the middle part is green color. You can see that the maximum stress exerted on the component is at the mark here, and the boundary brackets which is almost yellowish and a hint of red here. So the maximum von Mises stress is at 4.586 megapascal, which is at the boundary bracket. So for the maximum displacement, we can see that there is more color to this component. Okay, when the force is exerted from the top, the top part will be red, and then it will slowly distribute it towards the bottom, and there's a yellow, green, and blue until the bottom part. So as you can see, the maximum displacement is at the top, which is at 5.03 times 10 negative 3 millimeter. So that is the maximum displacement, which is likely because when the force exerted at the top, the force will be distributed equally to the bottom until the bottom. So that is why the top it have the maximum displacement, while the bottom have lower displacement than the top. Next, for the safety factor, as we can see from the diagram, the safety factor for this component is 101, which is very safe since it's higher than 1. So from the theoretical calculation, we can use the yield strength of the component used, which is 470 megapascal, and the sigma below we use the maximum von Mises stress, which is 4.586 megapascal, and then we have almost the same safety factor, which is 102.49, which is almost the same as 1.1 by 101. So the overall the component is safe to be used when the landing gear and when the aircraft is in static position. So that's it.
Okay, I'm Meng. I'm going to present the second load case for this project, which is the impact load applied on the main struck piston landing gear. So this main struck piston, the model that we choose to carry out both load cases is the Embraer Phantom 100, and the mesh converter study is already explained by Iman, where we decided to use 10 as our mesh size because the maximum wall misses and the maximum displacement will have the highest value when the mesh size is 10 millimeters we compare to 20 millimeters, 30 millimeters, and 40 millimeters. Come back to my load case. The boundary condition that I do is I fix the region at here with the bar of the main struck piston and also the nut hole here. The reason that I fix is because I want to identify the maximum impact force when the aircraft is landing. So this part is going to carry out the stimulation. So the purple arrow indicates the force that I apply. The force I calculated by using the studies and researchers from the Thomas Verbitsky, and I show it in the report. So after the simulation, you can see that the maximum wall misses is located at the red region here, which is the value is 7.289 megapascal, and the critical region, the number of knot of the maximum wall misses is at 1364345, which is located at here also. So you can see that after the force is applied, the hole is become bigger because the force is applied to enlarge the hole. So next, for the maximum displacement, it will be at the front of the hole because it is the first part that we contact when the aircraft landing. So the maximum displacement that I found is 1.328 centimeters, and also the critical region for the maximum displacement is at 12794. For the safety factor, we can calculate by using manual calculation, which is by using the yield strength of the material that we choose, which is ASYHFAN steels, divided by the maximum wall misses that we get. Then in result we get the 64.481, which is more than 1 and is considered as stable for throughout the load cases and also the force that we apply.
As a conclusion, the objective of the analysis is achieved. The objective is to observe the most critical part of the component after the load is implemented. For the load case 1, the critical part for the bone misses stress is located on the mounting port at the back of the main landing gear piston. Hence, it will fail first before other parts of the component. Next, for the maximum displacement, The deformation occurs throughout all the top part of the piston, most of which is at the upper part of the main piston. For the load case 2, critical part for von Mises stress occurs at the bottom bolt hole is because the distributed load is giving the largest value of bending moment at that particular point. For maximum deflection, it is happen at the end of the strut piston landing gear due it used to withstand the weight of the aircraft when landing the aircraft. That's all from our group. Thank you.